So why is so much of the variability due to sampling? This has to do with the mycotoxin distribution. So the mycotoxins are produced by fungi, and those fungi are not uniformly distributed among kernels. And in fact, the contamination rate in cases where people have looked at individual kernels has been approximately at 3 per 10,000 kernels, or 0.03%. So if you look at the concentration on a single kernel, it could be as high as 400,000 ppb. So that explains now why we can see this kind of variability in a lot depending on what sample, what of a number of samples was looked at. So then the situation is, if the blue line in this slide represents the level at which both the buyer and the seller agree is the maximum permitted level. If you have what is genuinely a good sample, that is, the overall level of contamination is below the maximum level, that would normally be accepted. There is a risk with these analyses in the case that you get one of those samples that yields a value higher than the actual mean value of the lot, then that lot would have been rejected. So that would be the seller's risk, the risk that there is a false positive test. If the lot is truly above the rejection level, then normally it would be rejected. But there is a buyer's risk, and that is if, as we showed in some of the previous slides, a sample was taken that doesn't represent really the mean of the contamination level of the lot, then the buyer could accept that result, and he would be obtaining a lot which actually did not pass the rejection level. So in terms of reducing that variability, we mentioned that there were several components that went into it: the sampling component, the sample preparation, the analytical method, and things that can be done to reduce the variability due to sampling are increasing the sample size, using a finer grind, doing a number of subsamples from the original sample, and the analytical end, and remember this contributed only about 1% or 2% to the overall variability. We could increase the number of measurements. So reducing the overall variability of the testing actually benefits both buyers and sellers. Okay, so it reduces the seller's risk of having good lots rejected. It reduces the buyer's risk of accepting a bad lot. Another approach that can be taken is to decrease the accept-reject level that's set. So if the statutory level is 20 ppb, the buyer could specify that product has to be less than 15 ppb. That reduces the buyer's risk of accepting a bad lot, but it increases the seller's risk of having a good lot rejected due to a false positive. So all of this information can go into development of a sampling plan. So what kind of test procedure will be used, what acceptance or rejection limit is set, and the outputs of that are a certain seller's risk, a certain buyer's risk, the levels of mycotoxins that you can expect in the product, and the costs involved with running that program.